All right, so we're going to start out taking a look a little bit about climate and what it is and how it works and such like that. A couple of things we need to break down is we need to define what climatology is. So when we look at the climatology, that's when we take a look at everything that we've recorded on specific factors about temperature and a few other things from the past and the present, and we're going to try to predict the future. So we're going to take a look at a couple of things, and we're going to discuss some of the things that what we try to do. Okay, so a couple of things that we look at here is the fact that we talk about long-term weather patterns, not just averages. So some of the things that we look at and we analyze is the fact that we look at the temperature for the object, for the area, we look at the precipitation, and we look at the wind. Now, I know this when we've discussed in class, we always kept referencing, what direction does the wind blow in our region? What kind of climate do we have? Or, does this part of the state get the most rain? Does another part of the state get the most rain? A couple other things that they deal with is the fact that we deal with something like the extremes. They'll actually put the highest and the lowest recorded. Thinking about this, we look at some of our states and we talk about a couple of things. Now, we look at Chicago, Illinois, and their highest recorded temperature is 41 degrees Celsius. Now, we're not going to talk about the formula real quick, but here's a quick way to think about Celsius to Fahrenheit. Just a super simple estimation. You double the Celsius and you add about 30. And that should get you really close to what it is. So that would make that 82. So that would make the high temperature there really close, but not exactly, close to 112. Now we look at negative 33 degrees Celsius was their lowest recorded temperature. So we double that, right? So that's negative 66 plus 30. So that would be almost 30-some degrees below 0 Fahrenheit. That's pretty daggone cold. Now, one of the things that we look at and we talk about is some specific information. Now, we're going to talk about what we use to develop. Look at some of the things that we're going to talk about here. Okay, so what we was going to talk about was the normals. Now, the normals comprise a list of data. Okay, so we include like the temperature, the rainfall, the wind speed and direction, humidity and air pressure. Those are all of our climate measures. But we collect the data for at least 30 years. Now that's a big thing. So when we look at our normals for a specific region, which we're going to take a look at our local regions and such, and we're going to take a look at those. And then we're going to discuss how they're related. But we call them the standards or the normal values for our area. So now it looks like when we pull up Hamlin, West Virginia, and we look at some of the climate normals from our area, it looks like, take a looking at that, our average high temperature and average low temperature for January, February, March, April, May, June, and we see a precipitation. We notice that the precipitation has a tendency to trend up through May, and let's see if we can take a look at it here and get the rest of the year here. Oh, there we go. Now, we'll notice that July seems to be fairly rainy. That's normally when we have the quick thunderstorms and such. But you'll notice this. Our average high temperature never really gets above a 90. But that's recorded data for over 30 years. So if we start looking at a couple of other pieces of information, we can get some ideas. Now, I think one of the things that being students and such, take a look at the average snowfall in inches. In January is 7, February is 6. So think about that when we compare stuff, okay? But there's some interesting data for us to look at. So what's the purpose of the normals? Well, that's trying to give people just a general idea of what's going on. Now we're going to talk about a couple of things of what causes climate and a couple of big effects. Now, so we've got some general concepts. Number one, if we take a picture of the Earth and we put our axis of rotation here and we put our globe here, and I know I did it. Oh boy, that was bad. Now, So we know that there's that, and we know we have something called an equator that goes like that, right? And then we have the sun that shines rays this way. So now my horrible, terrible, awful drawing here. So if we're looking at that, we're trying to figure things out. So the question is when we take a look at this picture, where do you think is summer? Is summer going to be up here? Or is summer going to be down here? So West Virginia would be about right there. So what do you think? Which one is summer? Is it summer in the southern hemisphere? Is it summer in the northern hemisphere? What do you think? So let's pause for a second and let you think. Now, let's tilt the axis this way this time. Let's draw our globe really horribly because I'm just high quality here. Let's put an equator in again. Boom, boom, boom. Let's put our sun rays in. Now, put West Virginia up here. There's West Virginia. So this time I'm going to go ahead and tell you this is going to be summer in West Virginia. Well, if you notice that more of our area is directly related to this. So we're going to talk about a couple of things and we're going to look at some stuff and try to get this into a little bit more detail. Now what we're focusing is something called a latitude, and the latitude is your distance from the equator, and we're going to break down a couple of the zones real quick, okay? Okay, so this is a little bit more high quality drawing, but you'll notice that we have a few of the lines of latitude drawn here. We have the 0, which would be the equator. Let me bring up my pointer here. So we have 0, which would be the equator, 30, 60, we're right in the middle between 30 and 60 in West Virginia. 90 would be at the poles. So when we look at the tropics, we'll notice this, that the sun's rays are coming straight down, okay? We're getting maximum effect. But when we get to the temperate zones, which is where we're at, we've got more of an angle. Then we got the polar zones, which is an even greater angle. And so we receive what's called less direct sunlight. Now, simple idea, simple concept, and stuff like that. You sit down and think about it when you're outside and you look at a sunset, doesn't seem as bright or as strong on your eyes as it does when you look straight up at noon. And that's part of the whole idea here. Now, we're going to break down a couple of these zones here, and we're going to break out some details on it, okay? Okay, so our regions that we're going to talk about are our tropics. Now, our tropics are located right around the equator. So if we just draw us a quick globe here. Oh, that was pretty bad. So the equator here. So we're going to have a band that's going to be the tropics. It's going to be somewhere centered right around there. So you can imagine they're going to have the higher average temperature. The temperate zones would be somewhere right above those. We got a specific area between 23.5 and about 66.5 degrees north and south. Okay, the polar zone is going to be our coldest. They average anywhere from negative 20 degrees Celsius is the low temperature to an average of about 8 degrees Celsius as our high temperature. Now, we're going to take a look at a couple of other things now. The topographical effects, what makes a big difference? Well, let's just take a look at West Virginia for just a little bit. And let's talk about it. Now, number one, when we're out west and where we're closer to, we have a little bit of mountains, but not a lot. We have a little bit. So this is kind of our topographical feature here. But as we move closer to the center of the state of West Virginia, we start noticing that we have a little bit change in the mountains. They get a little bit higher. Then we plateau off. Then we drop down to the ocean. So what we're looking at here, and all of our wind goes from this direction here. So it goes from west to east. So this topographical effect has some things that happen. Number one, The higher you go, the cooler it gets. Now, everybody in here has probably taken a shower or something. They got out of there and they looked at the mirror in the bathroom or whatever. You'll notice it's covered with steam. It's covered with water. It condensed. Okay? We see that all of the time. Whenever more moist air hits a cool surface, it condenses. We form droplets. So we know that. So our weather comes from the Gulf of Mexico, okay? So it comes from out of there, and it's carrying moisture. So we've got moisture here, but as it hits this mountain, it gets shoved up. So we start forming bigger and bigger and bigger and bigger and bigger and bigger and bigger clouds as the higher we go up the mountain. Now, the clouds don't make it quite over that. So what we see is on this side of the mountain, we see a lot of the precipitation forming on this side of the mountain. So if this is the Hamlin side of the mountain, it would get a lot more rain than the other side of the mountain. Okay? Now remember, this is moist air coming out of the Gulf of Mexico, moving from a west to east pattern towards us. It hits the slope of the mountain, it climbs up the mountain, it cools, condenses, and forms precipitation. So as that happens, we have that. Now, we're going to talk about a couple of other things, and we're going to look at a couple of air masses, or big flows of air that generally have a tendency to happen, and we're going to try to relate this to what's going on here. So we're going to take a look at a bunch of the air flows and air patterns and such, and you're going to notice that you're going to see quite a few of these that have a straight-in effect for us in West Virginia. So let's take a look at a couple of them. The continental polar, these right here. Now they're going to be a cold and dry. Now why would we say they're going to be a little bit on the drier side? Well, number one, let's take a look. Is there any major source of water in that area? There isn't. Okay? Now, when we get to the maritime, or the ones coming out of the south here, they have large sources of moisture in them. Okay? So there's chances that we can pick up quite a bit of precipitation. And we'll notice that this one here coming south, you notice how it hits the Great Lakes and such? We have a good chance of picking up what they call a thin dusting of snow, reminiscent of a lake effect snow. So when we take a look at that, there's a couple of things that we've discussed. Let's go back. Number one, hey, what affects the climate of our region? Number one, where we're at in relationship to the sun. Are we in direct sunlight at the equator, slightly tilted at the temperate zone, or extremely tilted at the Arctic or the polar zones? That makes a difference. Which side of the mountain are we on? Are we on the dry side or the wet side? Remember, the wet side of the mountain is the one that has what we call the windward side, the direction where the wind is blowing into. Okay? The leeward side is the opposite side. Then we have general flows of air masses that have a tendency to generally move masses of air across the continent.